Hello, my name is Paula Bedoya from the JBS Law Magnet. It is April 2016. Today I'll be doing the Calculus AB 2012 first free response question. It is, let R be the region in the first quadrant bounded by the x-axis and the graphs of y equals ln of x and y equals 5 minus x as shown in the figure above. Question A is find the area of R. So I have drawn out the graph that was given to us and labeled it with the respective equations. And basically how we're going to do this is we have to write an integral to find the area of region R. And since there's two equations and there's not technically one's not a top and one's not a bottom, it's kind of the x-axis, we have to separate it right here. And that point is roughly 3.6 something. 3.693 and 1.307 roughly. So our integral will look like this for part A. It will be from 1, because our first x starts at 1. That is where that equation starts, and it's respect to x, so we have to use all x values, to this midpoint right here because we have to cut it there, 34414, of y1 minus 0 respect to x d of x, and it's this one minus this one. You can do it the other way around, I guess, but that's how I'm going to do it. And then, oh my bad, this one is from 3.69344414 to 5 because that's where it ends on x of y2 minus 0 respect to x. So, since this is a calculator active problem, you can do it in the calculator, and you make sure to clear your equations that are in there. And then since I labeled my ln of x y1, we'll do that here. Ln of x, and our y2 is 5 minus x, so 5 minus x. And then we're going to window that from, I'm going to just say 0 to 6 to make it easier. And our y values can be 0 to 2. So it will look like that. And then you just press graph and you wait, because these graphs take forever and a half. So you don't really need to see it because I already drew it out. But basically, you can press second quit. And to do your integrals, you press math and 9, and you will have little integral. And we will just enter it the way you see it, the way we did it. So 1, 2, 3.69344414 of bars, y bars 1, because we put our first equation in y1, and there goes y1 minus 0, d of x, because it's all respect to x, and then you can just do plus your integral, once again math 9, and then it'll ask you the lower and upper boundaries. So this one goes from 3.693, I suck at math, 4414 to 5. And this one is from bars, y bars, enter. This is y2, so y2, there it goes, minus 0, all with respect to x, and we're done. You can press enter. It'll give you your answer. We'll round to the third decimal, so 2.986. Yes. So then we will just, that's the answer, 2.986. And that is how you do part A. Part B is asking, find the volume of a solid formed by revolving region R around the x-axis. So, revolutions, same concept, except you add a pi and you square it. Basically, you do this, and I'm just going to do a different color so I don't have to write it all over again. We'll do color blue. So, okay. B will be in blue. Oh, that is so off. Oh well. So yeah, basically just add a pi before that integral. Don't add it all the way up there. Can't coordinate my hands correctly. A pi, and then this in here, y2 minus 0, that will have to be squared. Over here too. That pi was supposed to be down here before the integral. And on the calculator, if you're lazy, like me, you can just press that by clicking your upper arrows, press enter, and I'm going to do it from the front, just to be like that. You can press second insert to put in pi, you put second pi, I put in E, second pi. There we go. Enter parentheses in over here, so second insert, open parentheses, and then just, you don't have to press second insert for that one, just parentheses, and then we squared, be that button, and same thing over here, second insert, second pi, second insert, open parentheses, close parentheses, squared. We're good. Press enter. Get your answer rounded out, 8.746. So that is the answer for B, which is revolutions. Don't forget. And that answer was 8.746. Alright, part C. This question is never ending. Thank you, Flores. Region R is the base of a solid. Each cross-section perpendicular to the x-axis is a square, right? But do not evaluate an expression involving one or more integrals that gives the volume of the solid. So, cross-sections. We can do it a different color too, but I will rewrite the integral because it looks pretty messy at this point. But cross-sections is a little bit different. Not too much. This one's just a square, so it's not that different, honestly. From the revolutions, it looks pretty similar, except without the pi. So, part C. Yeah. So, integral looks just about the same as revolutions, except without the pi. So, 1 to 3.6934414 of y1 minus 0 squared plus 3.6934414 to 5 of y2 minus 0 squared dx, dx equals, put that in your calculator once again, oops, once again, I'm so lazy, so just gonna enter, and then we're gonna take out the pi's because we don't need the pi's here. Just gonna Oops. Just a minute, where am I? Oops. Okay, alright. My life is becoming a mess at this point. Alright, awesome. Okay, definitely not gonna restart this video at this point. Definitely just gonna keep on. 3, that deleted, so 3.6, 3.6934414. Delete that pi. Wow, this calculator just hates me today. Having some technical issues. Please stand by. Okay. Delete that pi. Awesome. Possum. Delete that pi. And then we'll have the correct integral squared. And the answer is, yep, 7.84. Alright. So, 7.84. Gotta set this up all over again, don't I? And I'm on 10% battery. Awesome. Okay, so I'm gonna end this clip right here because obviously my life is a mess at this point.